Hello students, I am going to discuss about dienone-phenol rearrangement. What is dienone-phenol rearrangement? When this 4,4-dialkyl cyclohexadienone is treated with acid, then it is converted to a phenolic compound with migration of one of the alkyl groups to the adjacent carbon atom. So, this reaction is a reversal of pinacol-pinacolone rearrangement. That means a retro-pinacol reaction. Now, we see the mechanism. What is the mechanism? In first step, what happened? In presence of acid, firstly protonation of the dienone oxygen. What happened? After protonation of this dienone oxygen, second step, what happened? This R minus shift, this alkyl group shift to the adjacent carbon atom, and this step is a rate determining step. After migration of this alkyl group, here is a carbocation formed, which is a stable carbocation. In the third step, we see that after this H plus elimination, which is a first step, what happened? This type of 3,4 di substituted product is formed. So, in the third step, after elimination of H plus, which is the first step, this elimination we get 3,4 di substituted phenol. So, the driving force of this rearrangement is a creation of a stable aromatic system in the product. So, this is a dienone-phenol rearrangement reaction. Now, we see one example. This is a dienone compound, and in presence of acid, what happened? This type of phenol compound. Now, see the mechanism. In presence of acid, this oxygen get protonated, and after this protonation, what happened? This pi bond shifted here and form a carbocation here, which is a 2-degree carbocation, and the adjacent ethyl group migrate from this center to that carbocationic center. After ethyl group migrating, here a tertiary carbocation is formed, which is a stable carbocation, and after H plus elimination, this type of aromatic phenolic compound is formed. So, here is another example. Here we see this is a dienone compound, 2 double bond and 1 carbonyl group. This is called dienone compound. In presence of acid, we get this type of aromatic phenol. Now see the mechanism. In presence of acid, what happened? First protonated oxygen here, then rearrange this double bond, this pi bond. After rearrangement, this bond migration is happened. This bond migration occurs here, and after migration of this bond, H plus eliminate, and this type of phenolic compound is occurs. Here is another example. This is a dienone compound in presence of trifluoroacetic acid. This type of aromatic phenolic compound formed. Now see the mechanism. In presence of trifluoroacetic acid, what happened? In this oxygen protonated, and after protonation of this oxygen, we see which group migrate. Here two different groups are present, methyl and phenyl. Now see, phenyl group migrate from this center to that center, and after H plus elimination, we got this type of phenolic compound, not this type of compound, because the migratory aptitude of groups in general, pH CMe3 greater than CMe3 greater than MECH2 greater than methyl, initially formed carbocation. That means initially formed carbocation is more stabilized by this pH group. So here pH group migrates rather Me group. Now here is another example. This is also a dienone compound in presence of trifluoroacetic acid. What happened? This type of compound formed. Now see the mechanism. After protonated of this